Lesson 8.1b, sample spaces. This lesson is used with probability so that we can calculate the total possible outcomes. We're going to use a tree diagram. So we're going to find the total possible outcomes, and then we also might do some probability like last night once we have all of the possible outcomes shown. So let's look at example 1. We'll see how a tree diagram is started. It says a certain type of watch comes in brown or black, in small or large. So there's a couple of choices. Anytime you have a choice with these, that's where you're going to get another column for your tree diagram. It says find the number of color size combinations that are possible. So the brown or black would be the first choice. I'm going to title that column color, and you can choose brown or black. The second choice is the size, small or large. Well, there's two choices. So from brown or black, you know you're going to have two branches. That's why it's called tree diagram. You're branching off. So from brown, you branch off to small and large. From black, you branch off to small and large. That's all the choices. That's it. The last column would give you your total outcomes. Notice it says sample space. So you start from here, brown, and follow the branches. Brown, small, and that's the first sample space. Brown, large, the next sample space. Black, small, black, large. There are 4 possible outcomes then when you have brown or black, large or small when it comes to this watch. So you have 4 choices when you, let's say we're ordering it. So 4 different combinations. That's doing a very basic tree diagram. Any questions about that? So let's look at the next one that they're going to do a tree diagram, and then they're going to have a probability question from it. So it says the chance of having either a boy or girl is 50%. What's the probability the Smiths will have 2 girls? So when you're talking about this, you kind of have to think about it. Okay, for the first child, you've got to have a column. And for the first child, the Smiths could have either a boy or a girl. The second child, they could have a boy or a girl. Now, from child 1, if it's a boy, and then they had another boy, the Smiths would have boy, boy. If they had a boy first but then a girl, then they would have a boy, girl. If they started out with a girl with child 1 and went to a boy, then they have a girl, boy. If they started with a girl and had another girl, well, there's their 2 girls. There's 4 possible combinations. What's the probability that they will have 2 girls? Well, how many of the 4 has 2 girls, Mason? 1. This one right here. 1. So 1 out of 4 possibilities would get those Smiths 2 girls, which is also 25%. Yes. So all of our probabilities we're going to give as fractions in simplest form. So 1/4. Question.
You know how you have the 2 boy girl and then boy girl boy girl? If you multiplied 2 times 4, you would always get 8 with that, and that would be your answer. And then.
Well, there's only 2 and 2. And I know what you're getting to. It's called counting outcomes, and we're going to get to that probably tomorrow. Yes. Question about this sample space. Okay. All right. So let's go on to some of the ones that we're going to do. Some examples. It says for each situation, make a tree diagram and show the sample space. Then give the total number of outcomes. So the number 1 is choosing an outfit from a green shirt, a blue shirt, or a red shirt. Then we're going to choose from black or blue pants. So green shirt, blue shirt, red shirt. Everybody got that written down? Green, blue, red. And then black pants or blue pants. Green, blue, red, black or blue. Okay, I'm going to change this up because I don't have space on that to do this. So we're going to do it like this. Now, we're going to do column 1, which is the color of shirt. Okay, so we're going to do the shirt color. What were the 3 shirt colors? Emily.
Green, blue, red.
Green, blue, red.
So I'm going to do green with a G. What was it? Blue?
Blue, red.
Blue and red. Now when you start this, you got to be careful about your spacing, okay? Because you're going to have to branch off. You don't want them to be too close together, or you don't want to be too far apart that it's going to go off your paper. So you just got to be careful. Now we're going to talk about the pants. And the pants were what?
Black and blue.
Black and blue. Well, B was for blue, wasn't it?
Yeah.
Right here. So we got to be careful. For black, I'm going to go BK. Black, and then blue is just B. So from green, I'm going to go black or blue. From my blue shirt, I'm going to go black or blue. And from my red shirt, I'm going to go black or blue. Now, this is going to be over here my sample space. So if I go from green shirt and black pants, I would have G, BK, green and black.
Yeah.
What's my next one?
GB.
Green, blue.
Green and blue. What's my next one?
Black,
Black and blue. Well,
Blue and black.
and blue, blue.
blue, blue.
And then blue, blue.
Then red, black,
Red, black,
and red, blue.
and red, blue. So how many are in my sample space? 6. 6 possible outcomes. 6 possible outcomes. Are there any questions? Okay, let's just say, and I know that there wasn't this on there, but just so we have some practice at probability, what would be the probability that we're wearing a green shirt if we picked one of those outfits at random? What would be the probability we're going to wear a green shirt? Mason.
1/3 or 33%.
1/3, because if you look out of those 6 outcomes, this one has a green shirt and this one has a green shirt. So 1/3, 2 out of 6. Also, you can look on this side. If it's just referring to the green shirt, how many shirts are there? 3, and one of them's green. So all your combinations together, you're only still going to have 1 out of 3 that's being green. Okay? Well, on the flip side of that, what would be the probability that we're going to wear black pants if we picked an outfit at random? What's the probability we're going to have black pants, Nico?
1/2.
1/2. If you look over here on this side, that has black, and that has black. 3 out of 6, which reduces to 1/2. If you just look at the pants, though, how many different colors of pants are there? 2. Black being one of them, 1/2. So the probability of getting black when you pick an outfit at random is 1/2. So you're going to be doing some of these tree diagrams. I do have a paper for you. Do you have any questions on setting those up? Any choice you're given gets its own column, and you continue branching out until all the choices have been made. Then you follow each branch to get to the sample space from the left to right.